Oh, totally amazing here. Greetings again, dear lovely viewer. The home of scientific knowledge, truth, discovery, research, and of course, electrical experiments and repairs since the 1st of January 2K19. And once again, greetings again, dear lovely viewer. Sorry, I haven't put out a couple of videos for a while now. I've just been busy, preoccupied with other things. As you can see, a TV has gone. No, it's not broken, it's not sold. It is here. It's just that I've had to move this for this particular experiment and a repair, and also for other things that are planned as well. So anyway, this video is dedicated to Wayne, and also for Dave, and also for Natalie. And basically what we're looking at here is this repaired power inverter, and we'll just show you that now and what we have in store for today. Now, word of warning, just before we go any further, this experiment and what we have here does contain the risk of fire and also the risk of coming into contact with inverted mains voltage. So, of course, there is not to be the consumption of alcohol or cigarettes, as not to impair our judgment. So anyway, and I'm also not responsible for any idiocy or whatever you choose to do as a result of following my my gubbings and dealings with here. It's not always advisable to copy what I do. I'm just demonstrating this stuff purely because I can. Doesn't mean to say that it's good. I do these things so you don't have to. Anyway, enough of the mumbo jumbo. Let's have a look at what we've got and let's get cracking. So, this is a repair that was brought to me, and what we have here is basically a 3000 watt inverter from Ring Automotive. It's 12 to 240, and if we look here, there's our mains output for 240. There's some sort of LAN cable there for something or another, and of course 3 status lights, of course a power switch. Now on the back, this is where you would obviously connect this to some sort of automotive battery, which is preferred, or I suppose some sort of petrol generator or whatever. The black one here, that's an earth lead. We'll come to that in a moment. The red here symbolises basically live or line or positive. The black is neutral or negative. Now, instead of using car battery, I have my sacrificial stand-in EP907 bench power supply that can put out a maximum of 20 volts up to around 10 amps. Now, we are only working with 12 volts here, and we only unfortunately have 10 amps, so that's going to give us an overall power rating of 2400 watts, because as you well know, watts equals your volts times your amps. As 240 there, the output, we have 10 amps as the input, is only going to give us 2400. So of course, if we try to do anything more than that, what we should see is a status light that would illuminate. We'll get to that in a moment. Now, of course, we have this connected by some household flex. This stuff is only lighting flex out of household wiring and is only actually rated for 10 amps anyway. That's not really a problem because all we have is 10 amps that we can work with in any event. So if anything does go wrong, it's probably only going to be a flex, and we don't really need anything more. As you can see, we have this wired in its respective ways. We just need to make sure that's not going to short out either. Let's just move that out of the way. So basically, the blue is neutral here, and brown is line or live. And the black that we have, I'm going to do something incredibly stupid, which you should never do. Basically, here on the top of my bench supply, as you can see there, I don't actually have an earthing mount, so what I'm going to do is I'm just going to take this silly thing, I'm going to connect that anyway, sort of line has come off, so we'll just double check all of this in a moment anyway. Let's just tighten the neutral up, move that out of the way. Now what I'm going to do is, with that black wire that's here, I'm just going to take that, and where that metal grate is, I'm just going to sort of, silly people out there, just sort of shoehorn that in there, which is a rather silly thing to do, just purely in case there's any sort of, that comes into contact with any high voltage. That could be quite bad, but fairly sure that's not going to happen. I'll just sort of shoehorn that in there like so. It's not sort of staying in properly. There we are. That's why, as I said, you should never copy this. It's purely there's a danger of things going horribly wrong. Hopefully that does not happen. So that's what we have here. Let's just sort of move that so you can sort of see what we have going on. And of course down here we have our displays. Oh, there's me knocking other stuff over, which is not good. As I said, I've been incredibly busy. Also, what we have for the testing this thing, we have a multi-function tester, and this has a plug on the end of it, so we can plug that into here just to see what we get. And of course we have our 3 plugs: line, earth and neutral. Now just before we go any further, I just want to clarify something with you, that when you're using these sort of function testers, you can't go doing insulation resistance tests or anything on these, because you'll end up destroying the unit. And you also have to be careful not to get your wires crossed or reverse the polarity on the input, because you'll destroy this unit. And again, as we said, on the output here, this is pretty dangerous, because we're going to be expecting at least 90 volts and hopefully higher, up to around 240. Getting 240 out of it might be a problem, because as I said, we only have a maximum of 10 amps and we can only really sort of stretch this to around 12 volts. So we'll see. And it's time to have a beer. Of course. And what we also do have for other aspects of this test, we also have a soldering iron. So something a little bit higher powered. Well, the good thing is with this, anyway, this has a sort of variable, some sort of varistor in there, variable resistor or potentiometer. So basically what happens is when that's off, and then as you turn that dial, basically it starts to draw more current. It drops the resistance, more current is allowed to pull. Now the thing is, there's no way that I'm going to get maximum output on this, because I only have 10 amps. This soldering iron is rated for 13 amps and actually is around 3000 watts. So what I predict should happen is this should detect a voltage drop and a sort of undercurrent and an undervoltage. Protective measures would come from this inverter and it should shut down. That's what we're actually looking for. Over voltage, unfortunately I can't really test that on here, as my bench supply isn't nearly enough. And of course the over amperage I can't really test on this either, because simply the cabling I have is not really sufficient. Now just before we do get started, these inverters, as I said, they're normally run off of some sort of generator or car battery. Car batteries anyway, as you well know, have a great deal of amperage output. Now, if any of you are wondering, but surely the car battery kicks out around 40-50 amps or more. Yes, it does, but don't forget, you sacrifice this when you're stepping up a voltage. You're going to lose some of your amperage anyway, That's just the laws of conservation of energy and the laws of thermodynamics. So you will lose certain current as you increase your voltage, and if you increase your current, you will always lose a certain amount of voltage. Those losses are generally in the form of heat. That's usually what will happen there. So let's get this powered up. It's sort of open there. Now I'm pretty sure that my lab supply, this darn thing, let's get that out of the way. I'm pretty sure that it is actually earthed. It should be. What have I done there? I've got that sort of hodgepodge of a mess. Yeah. Just need to check down the back. Nothing is shorting out, because I don't want to destroy somebody else's equipment. Now, what it is worth noting is that with these inverters, they can be used pretty much by anybody from builders to working in areas where you're off-grid. So if you have a battery array and you don't have any sort of mains power, then yes, you can use that. It's useful for people who engage in camping, and in Wayne's case, I think he actually does some sort of car boot sales or something like that, trunk sales or garage sales, whatever you want to call them, and where he's remotely travelling around, he wants to show other people devices working. So of course, if it's mains electrical devices, then he would require an inverter to do that. Now these things can be purchased fairly cheap. This one is not cheap. It was around £500, hence why I don't want to be doing major experiments or teardowns with this any more than was necessary, because it's not my equipment, and I would not imagine that my customers would approve of me carrying out certain experiments with their equipment. So needless to say, that will not be happening. We're just going to confirm that the thing is working, check for under voltage and under current, and we already pretty much know that the over voltage side will work anyway. I've already sort of tested that out of here, and that was off camera. But let's have a quick look anyway, get the thing powered up and go from there. He has a big glug of nice cold beer. That's fine. That's not going to hurt anything. So let's just get some power into sort of a thing. Let's just move this out of the way and turn our power supply on. And as we can see, we have a green light on from our inverter, and lab power supply. Let's just set that to about 12 volts. There we are. And we're only pulling around half an amp to 1 amp. That's because this thing is still going to draw some current anyway. Now, with the internal circuitry on this, as far as I know, it's not going to go dumping out the full voltage straight away and the full amount. It would actually require a load to do that, as far as I know. So we should have a standing voltage of anywhere from around 50 to 100 volts or so. So while I have another glug of beer, let's just plug this in and then make sure that's all seated correctly. Turn this on. And as I said, we are working with potentially dangerous voltages. And there we are, we're actually seeing 93.3 volts. That's actually fine. And 49.9 hertz, which again is fine, because 50 to 60 hertz anyway is the standard main supply. Well, we will see some fluctuations here if we increase the voltage input to no more than 15. We'll see that this should remain sort of around. If we drop the voltage right down, then we can actually see the under voltage protection work. If we go to below 10, there we go. the undervoltage kicks in, light goes red, and the unit should shut down. So you have to turn that off. That's obviously indicated that there's been a voltage drop. So that's fine. So turn that back on. And there we are, back up to around 90. Let's do the test again. The voltage at top there should, we have an amber. That's right on 10. That corrects, so that's fine. If we drop to 10 again, there we are, it's a warning. So the undervoltage protection works. Now the reason for that is, if you have undervoltage, typically what that would mean is that you would have a higher resistance somewhere within your circuitry. Basically, that's just to prevent a fire. Overvoltage could also cause that sort of thing as well. So that's why these generally would have this protection there. Let's see what happens when we take this thing into the red again. So we're sitting around 92.5. Let's take this down to the red and see what happens to our voltage at the top. As you can see, straight away, it went down to 80 and then is shut off. And if we were to suddenly reapply 12 volts, well, that's not going to work, because once you've already gone into an undervoltage state, the MOSFET in there's MOSFETs that would just simply shut down and prevent this from essentially pushing through a supply again. So then you have to turn the unit off, turn it back on once you've cleared the fault, solved it, and it works. And as we can see, we're back up to 92.3 volts again. Let's see what happens. Turn this off, and we'll go ahead and we will connect a lamp and see what happens there. So there's a lamp, and let's see how many amps this pulls. Here we go. There we are. There's the lamp on. That's now working. 96.3 volts, that's fine. Around 2 amps. And we'll just set that. There we are. That's perfectly fine there. And again, I can turn this off. And that's the lamp. Our amps have fallen away fine. Voltage is gone. Turn this back on. There we are. There's an initial rise up to 4 amps. This is initial influx voltage, and then very quickly that's just fallen away. But that's obviously because this unit is powering up. 96 volts overall here. And that's fine, because this is actually a 2 amp lamp, so that's rated 2 amps anyway, so that's fine. Let's turn this off. Try with something else. Let's use a soldering iron for some fun, and let's get that powered up. And again, what we also can test now as well is the what happens if we try and pull more current, so we can do that too. So here we have our soldering iron, and we'll actually see if we can melt any solder on there. So what we'll do is, now that we have our system all connected, turn on. Straight away 149 volts now, so that's what we would expect. So quite clearly I was indeed correct anyway, that this unit will only pull what it actually needs. Let's go ahead and turn the iron on. Slight voltage drop. So if I turn this all the way to off, we are on here, it's sat around 106 volts. Let's go ahead and turn this on and find out at which point that this starts to give us an error. You may or may not be able to hear buzzing. Oh, look, we're pulling around 4 amp. If I turn that down as well, then at the moment that's resting at 0. That's around 1 amp. Second I turn it on, that's 2 amps. Take the power up to level 4, and that's 4 amps. So roughly each number 1 on here corresponds to 1 amp of pull, which actually ties in quite well. So then what we know is that the inverter's doing its job properly, and it all matches with relation to our lab power supply as well. Let's try and pull 5 amps and actually see what happens. Right, well, we've got to a maximum and we are not seeing any problems there. I was actually thinking maybe there would be, but that appears to be just fine. It's perfectly fine. And let's see if we can actually start to melt any solder. We should have actually removed that sort of kind of ridiculous plastic cable tie on that. This isn't normally a soldering iron I actually use. Let's just go ahead and remove that stupid plastic tie if we can. No, so don't really need that on there. It's just going to get us in a horrible tangly mess. Now, the benefits of this as well, we're actually doing a load test on our inverter as well, and we're sat quite nicely at 104 volts. Everything is all appearing nominal, and as we can see, light there is illuminated and the light here is green. And the beer is good.